Welcome to Safety Spectrum, your environmental health and safety connection. This program is a presentation of the Michigan Safety Conference. For almost a century, the annual conference has provided credible educational opportunities and valuable support to the safety and health practitioner by offering 120 instructional programs along with exhibits highlighting the latest in safety equipment, instrumentation, and demonstrations. To learn more about the conference, please find us at safetyconference.org. Welcome to Safety Spectrum, the podcast of the Michigan Safety Conference. I'm your host, Sheila Ide. The Michigan Safety Conference exists to champion a culture of safety and health that empowers individuals and organizations to protect people, preserve the environment, and promote well-being. Our program today is Noise Conscious Engineering and Architecture. One of the more insidious industrial hygiene challenges is determining cause and mitigating noise-induced hearing loss. Our speaker today will discuss the hazards, measurements, and possible solutions, as well as making the case for advanced engineering versus retrofit. Eli Franklin is an acoustic engineer at Memtech Acoustics, who has served on and led industrial projects providing evaluation and noise-reducing solutions to a variety of businesses. Eli has a mechanical engineering degree from the University of Michigan and a certificate in energy and sustainability from U of M as well, a topic of which he is a strong proponent. Thank you for joining me today on Safety Spectrum, Eli.
Yeah, beautifully put, Sheila. Thank you for having me. I'm excited to be here.
So why don't you tell me a little bit about MTech Acoustics and your role?
Yeah, so Memtech Acoustics, we design and integrate solutions for noise and vibration. So we provide acoustic consulting, and we primarily focus on actually getting data in the field so that we can apply that into either if we're referencing that data as here's what the base level is now, here's our objective, and we can provide an objective solution, or it's just for informational purposes and consulting. And we work through a variety of industries. We obviously industrial and occupational noise exposure, environmental noise, architectural, manufacturing, municipalities. If there's noise and vibration, we're generally there. So we're a small specialized team. We do engineering first. We like to, like I mentioned, we quantify the problem before we talk about solutions. And my role here at Memtech is primarily field data acquisition, analysis, reporting, and direct client engagement or engineering work. So, yeah.
You do it all, soup to nuts, A to Z, right?
Yeah,
Make the
turnkey too.
evaluation and right to the solutions and modifying workplaces. Okay,
Yeah.
to begin, what is the threshold for hearing damage? Who is at risk, and how can businesses determine if their employees are at risk?
Yeah. So I'd like to start by kind of defining how sound is measured. Just first, basic stuff like decibels or logarithmic. And generally, a increase in 10 decibels is roughly twice the loudness subjectively. So plus 10 dB, 80 is going to be half as loud as 90, and then 100 is going to be twice as loud as 90 decibels. And then frequency is going to be just as important as the sound pressure level when we're considering the risk as well as solutions. So, and then talking about the ear and how it is that we perceive sound, you have and what hearing loss is, how it happens. You have these hairs that are basically just receptors, are receiving the sound pressure, and on the outermost layer of the cochlea, that snail-shaped part of your ear, you have the longer hairs that are more susceptible to higher frequencies, and those ones go out first because they're on the outermost layer. And then as you get in deeper, where your low frequency is perceived, those go last. So for hearing loss, you'll see the speech frequencies that are associated with speech intelligibility, the consonants, the T's, the C's, those will go first. So high frequency, once you start losing that, then you know you're in it. You have hearing loss. Hearing loss is permanent. It gets worse over time, so it's cumulative. You may have a little bit of hearing loss when you're working, and then over time you end up leaving that environment, and it could still progressively get worse just with age, even when you're out of the environment. So OSHA, of course, has thresholds for how they define hearing loss, or how they define when hearing loss is you're at risk for. And so those are with those time weighted average thresholds. And yeah, I'll give you I'll give you a chance to respond to the first little bit.
So, what would be like normal office levels of dB? What
Yeah.
dB level is that? So it gets a comparison when you talk
So
90 compared to something else.
right now, when we're having this conversation, we're in, maybe the 50s. Just if there was a sound level meter, now decibels are going to be also um, determined by the environment rather than just the source. If you're further or closer to the source, you'll have a different measurement. So that'll get into some of the importance of actually measuring sound properly. But right now, we're like 50 to 60. Now, when you go into the action level criteria defined by OSHA in a workplace, that's 85 dBA. And so that's over the course of your entire shift. If you exceed 85 by for 50% of your 8-hour shift, then you'd be at the action level where protection may be required. And then 90 is when engineering controls are required. And then 140 decibels is pretty much the threshold for instantaneous damage. It's extremely loud. That's like a gunshot being, uh, going off right next to your head. And so that is the threshold that OSHA also defines as you need hearing protection immediately. You need engineering controls. It's unacceptable.
So if the employer's doing some noise level monitoring, he's got to monitor employees through the entire 8-hour shift.
Yeah, we see that with dosimetry. Sometimes I'll get a dosimetry report and notice that they may have taken them off for a portion of their shift. But the breaks, when doing occupational noise exposure, you're including breaks, you're including lunches. If they step out to their car, they wear it the whole time. So your noise exposure risk is the entire duration of your shift and everything you do.
Okay, 'cause that's what I was trying to get at, that it also counts the times that you're at lunch or taking a break or what have you, right? Because it's the overall cumulative effect.
Yep. Yep.
So, what common issues do you see in the workplace related to noise? What's causing the problems?
Yeah, so noise is a form of inefficiency, just like heat. It's wasted energy, so it's usually signaling that there's something worth investing in. This could just be something like a maintenance issue. You have squealing bearings or loose panels, or there's some fatigue and vibration happening. That's kind of an easy win because not only are you preserving your equipment, but you're also addressing the noise. But another common issue is that equipment isn't spec'd properly. So OEMs are supplying something that's necessary, like a hydraulic pump or a vacuum unit, and the actual specifications that outline what the sound power of this equipment is, isn't addressed, and that is the earliest time that a facility could catch that they may be at risk. Uh, I've seen a pump unit. I was in a very noisy room, and it was just like a waterfall, like Niagara Falls on all sides of me. And I was trying to determine where this one specific, tonal noise. It was. I could hear it. I knew it had a source, and I had to trace it and spin around and put a clipboard up to my ear. And I eventually found these vacuum units, and there were 10 of them along these part pickers, and when I looked at the spec, I backtracked the model number. I found that they had a spec of 80 decibels. So if your threshold for action is 85, if that's the criteria, 85 decibels, and you have 10 pumps that are all producing 80, then you've just invited in something that's going to add up all the way to, almost 80, 88 decibels, and you're already got yourself in trouble just from receiving an equipment where the specification may not have been double checked. And then the last would be, spacing and surface treatment. So you have a lot of equipment and a lot of workers centralized all in one area. Putting all your noisy stuff in one space, it's all going to add up, and then having the surfaces in the area that you're working in being reflective, that sound's gonna bounce around and just be like, if it's an echo chamber, it'll add up as well, raise the noise floor.
So the person's position in the midst of the noise producing items is probably key to what you're actually going to achieve there, in not only in the exposure and also in mitigating the exposure. So positioning's got to be important, I would think.
Yeah, it limits a lot of the ways that the approaches you could take to address it. If you're limited on floor space or you're limited on, we have to have this much equipment and it needs, 1 or 2 operators, then, if the equipment itself is noisy, then remediation can't always be a big box that you put around it or walls that you're putting up because people need to access it. They need to be able to do maintenance. So catching it then is better than trying to remediate.
or designing it in to begin with.
Sure.
Though, it's funny. I remember when I was doing noise exposure training, I would use the example of noise is unwanted sound. I mean, you go to a rock concert or something, you want to hear the loud banging and
Yeah.
booming. So, and I'll say, do you ever get back in your car after you've been someplace noisy and you've got the radio up, but you don't know you put the radio up until you get back in the car the next morning and it blows you right off the seat. So that's a temporary hearing shift. We do it often enough. Then you add
Yeah.
that to industrial exposure that just make because I'm older, so I have a hearing loss. I wasn't necessarily working in high noise areas that often, but
Mm.
aging does have an impact as well.
Yeah, those hairs get stiff over time just naturally. So better to let it happen naturally than to force it, you know?
So, in your experience, what costs or trade-offs could be suffered by business by not addressing noise control engineering?
Yeah, right off the bat, you have all the visible costs. If this isn't done proactively, then you could have OSHA citations or workers' compensation or insurance issues because people have experienced hearing loss and they're reporting that. But then there's a lot of hidden and cumulative costs that have statistically already seen progress in things like Ford, where Ford plant has addressed noise quite well because they were noticing the ongoing hearing protection costs, hearing conservation programs. So companies that are constantly supplying hearing protection controls, that's money being spent in tons of facilities, as well as keeping people tested with audiograms and training process. So by the hidden and cumulative costs, uh, eh, sorry, the personal protection that you're wearing is the cumulative cost, and it's also the kind of the last rung of that OSHA hierarchy. It's the last control that you want to have is something that you're constantly paying for and having to wear all day. The next would be the machine maintenance neglect. So if you're hearing noise is vibration. It's vibration in the air. But if something is off balance or something's not working properly, it's going to make more noise. And ignoring that, not only are you being exposed to the noise, but something's wrong with the equipment. And if it's quieter, then oftentimes it's working more efficiently. So you have more life out of your machines. And then, of course, you have communication errors and safety risks. If people can't hear a verbal cue or an alarm, somebody's backing up in the forklift and it's too loud, then that's a huge hidden risk in general noise exposure. And then just fatigue and happiness in the workplace. If people are dealing with that all day, tensions get high. Again, I think heat and noise have a lot of similarities. On a hot day, you see a lot more aggression coming out of people, and I think if I was dealing with something that was just tonal and worrying all day, that would add a lot of stress to what I'm doing.
I think one of the complaints about these data centers is the constant noise that they produce 24/7. I think you and I have talked about that a little bit. Even low
Yeah.
frequency noise can have a physical effect on you. If only that it's annoying, you can't turn it off.
Yeah, for sure. And happening all night, it's extremely noticeable. That's a time when you're expecting silence and it's going 24/7. So all through the night, you're going to be hearing something, you're going to pick up on it. And there's some psychoacoustic effects going on there where you just kind of get attached. And even if it's not that loud, it's your brain's focus.
And it was interesting what you said about communication because I won't describe the job exactly, but it was people had to run these pumps and I was trying to put them in hearing protection and they complained that they would not be able to hear crucial commands. And I said, do me a favor, put on the hearing protection, run the pump, and then talk to each other. And they go, wow, we can actually hear what we need to hear.
Yeah. Yeah.
So equipment is sophisticated enough to be able to block out noise.
And sometimes that has to do with the frequency. If you're dealing with a high frequency noise, then your hearing protection is going to be pretty effective at blocking that. Where our voices are going to be kind of on the lower to mid frequency range. So a booming voice might be better at penetrating through some hearing protection than like a high frequency or tonal equipment.
And I noticed I already can't really hear sometimes when people are just talking, you lose the consonants or something, and all of a sudden it doesn't make sense what somebody's saying. So it's really once you have a hearing problem, it is insidious. It just takes over your life. It really does. And
It
you're
does, yeah.
constantly what annoying
Yeah, yeah,
everybody. But low frequency can be just as dangerous as high frequency. Is how I understand it.
for sure.
When a noise source is putting employees at risk for hearing loss, what steps or improvements can be made? What kind of examples have you been able to apply or use?
Yeah, I mean, there's a ton of approaches to actually remediating. Of course, again, we're trying to avoid remediation, focus on designing in the first place. But for us, we always start with data acquisition because without actually quantifying what the problem is, then remediation is just guesswork. Like we're not throwing spaghetti at the wall and seeing what sticks. So we got to characterize what our noise source is, like the frequency content, sound pressure level. Is it directional? Is it cyclic? Is it continuous? And then as well as our receivers, who's receiving, who's being exposed to this noise, where are they located, and what is it like in their position, rather than just some objective, characteristics of the source. And then from that, with that data, we can kind of set an objective target. How do we want to reduce the exposure? Are there operational controls that can be put in place where they don't, have to work at this machine for a certain amount of time? But the hierarchy for engineering controls generally goes with, of course, eliminating or modifying the source. So, can the equipment be changed or altered? Speed, the load, the temperature, the maintenance that needs to be done. These are kind of root cause first step. You'll get a more long term solution. And then the other steps, which are more in remediation when you're trying to address this exposure, is the distance and the barrier. So that the median that sound is traveling between the source and the receiver. Can you have this worker be further from the machine, or can you implement a booth or a barrier between the operator and what they're working on? But that's where frequency matters. Like I mentioned, high frequencies won't be as good at penetrating something like hearing protection. Same thing is true with barriers. And this is where like it's a good analogy to say you hear a vehicle driving down the road, they have music blasting. Um, while they're blasting their music, you're not hearing the snares and the hi hats and the high frequency components. You're hearing a booming bass as it drives by, because low frequencies are much more likely to excite structures and pass through or propagate through materials. So it's a good thought to relate. When a car passes by, you hear that bass booming. You don't hear the high frequencies. The same is true in a workplace when you're trying to reduce noise exposure. So when we're implementing barriers, we're definitely considering what is the frequency of the source. Is it just going to boom and shake a barrier that you put in front of it, or is it going to be stopped because it's a higher frequency? So enclosures are good, better than barriers, better than the distance separation. But enclosures, and meaning that we have a roof on it now, we have a door to access. They're more complex and they're going to be more expensive, and you have to consider maintenance and heat buildup and airflow. Can you structurally support it? Can you get a forklift in there? Every opening could be a flanking path too. So even if you have an enclosure around something, if you have a louvered vent, you could still have some noise passing through. But generally, that's kind of how that noise control is approached. Can we modify and fix the source? Can we increase our receiver's distance, put up a barrier, or can we enclose the machine? And that's pretty much it. Until, of course, the actual personal protection is that very last step.
I think one way to really illustrate that is I'm sure we've all been in restaurants where they're into the whole ambiance of the open industrial looking ceiling, and you try to carry on a conversation, all that noise is just, it surrounds you because there's
For
no
sure.
barriers. But then, as you point out, you have heat, air conditioning issues when you put barriers or put ceilings up or what have you. So airflow is. So what happens typically when you walk into a business? Are they expecting you to just walk in and give them a magic solution, or what happens?
Yeah, the wand, the noise wand, we wave it around and the noise goes away, and then they pay us and we're all happy. No, usually it's, the first thing again is we're trying to get data, so we'd like to evaluate the machine. Is it running properly? How much are they willing to invest in a solution? Is this a machine that they want another 20 years out of? And they want, the people that are working on it, the receivers of the noise, to have a happy experience for that whole time. So we try to just get as much data and feedback as possible so that the solution is really tailored for the specific equipment. And again, following that hierarchy, if there's something that you can do to the machine itself or to the equipment, then that's going to be better than just saying, let's put up a barrier and foam and absorb the noise that's bouncing around. You mentioned in a restaurant, we do a lot of architectural work as well, where we're trying to do that. We're reducing the reverberation time, and you can't just throw up barriers and absorption willy nilly. There's a decent process for data gathering and for resolving that issue as well.
I think you mentioned earlier about Ford has certain things built into their quotes or bit specifications for noise.
Yeah. Yeah, they have standards for the amount of noise that equipment they purchase, so that they take into their facilities, such that all of the equipment operating together won't exceed a certain sound level that's going to require hearing protection or additional retrofitting. And so I believe it's about 77 decibels. And then it's important to also clarify that sound power is different than sound pressure levels. So when you buy a speaker, you don't buy a 100 decibel speaker, you buy a 100-watt speaker because you're buying the sound power. This is its ability, its capacity for how much noise it's going to produce. It's acoustic energy. As I mentioned before, sound pressure also includes the distance and the environment and all these other factors. So the specking out and seeing incoming machinery, you're going to see a sound power spec rather than a sound pressure. Back to the point though, Ford does limit the amount of noise, the specification, what that they put a cap on it. That way, if they take in 20 of these machines, put them all in one facility, their accumulation of noise will not exceed that threshold where they need to implement controls.
That's amazing. They're able to get that to happen because they're large enough, I suppose, to be able to
Yeah.
demand that. So that kind of slides right into our question. Can you address the difference between advanced engineering and retrofit when it comes to noise reduction? Really costs, you know?
Yeah, yeah. So being proactive about it, and like the Ford method of putting the pressure on the OEMs, it's the best time to solve for a noise issue is before the machine is built. Just all the details like gears, fans, pumps, and turbines, these can all be engineered more quiet from the start. Often it's not because of costs and for budgets, but it correlates directly with efficiency. So at the end, not un, it's kind of like a backwards flow where if Ford puts this pressure such that OEMs who want to supply to them have to meet that criteria, they will also very likely end up making more efficient, smoother flowing machinery that have better tolerances, less waste. So it's kind of upstream re-engineering costs and initial investment, but downstream the remediation is always going to cost way more.
Okay, if I can work this through my non-engineering brain, you have parts that are moving or rolling or touching. You have ways to push cushion them so that they don't touch each other, they don't
Yeah.
roll, they don't make a noise.
Yeah, there could be, for example, I've seen a part that is cutting plastic, and it's
Okay.
basically just a big wheel with blades on it. And as the blades spin around in their housing, the tolerance was such that it was creating pockets of air, and that pocket of air was creating a bunch of energy, kind of almost exploding, and it was turning into a siren. So they built a siren on accident into their equipment. And then same thing, like a more simple example, if you have airflow, you're trying to draw a bunch of air in for cooling, and you have sharp corners, air doesn't like to, behave very well when you're dragging it through a sharp corner. It's going to have turbulent airflow, make a lot of noise. So smoothing out the corner of an air intake or backing up whatever valve you're using to control the airflow, that will support in a quieter, the air is going to flow in laminar flow. It's more smooth. It's not jostling. Air makes a lot more noise than people think. So that's a just smarter geometry and smarter controls for fluids like air. That makes things a little more quiet, and just from the engineering side.
It's interesting. I have a odd example of that. My trucks, the pickup trucks, they have a tendency to rust around the wheel well. Don't know why they make
Mhm.
them like that, but they all seem to rust if you look at a pickup truck. And my husband recently put plastic flares, they call them, that fit around the wheel well, and because
Mhm.
it kept constantly standing and repainting. So this just covers it up. But he couldn't get the rubber piece to fit underneath it. So when we drive, you hear this whistling sound,
Yeah,
and we're
that's
assuming
funny.
it's air being trapped with that flare. So
Yeah,
that's
yeah, it
exactly
makes
what
a
you
lot of
described, I
noise.
think.
Right. No, that is. Yeah, so I mean, like, that's where the engineering side, that's the advanced, like, proactive, what we can do at a time. And then, retrofitting, I mentioned before that you're taking up part of your workspace with the retrofit. So, if you were to try and now address your truck's fender airflow issue, you don't have much more room to work with. You have to just start throwing more things in there and seeing what'll stop that airflow. But the same is true if you're trying to address machinery that's making a lot of noise. That's a much bigger noise problem. You need a bigger box to put around it, a bigger barriers. So, when we're addressing retrofit, we do the same protocol, get as much data as we can, measure, but we are working in an existing facility. So, our measurements have to be more specific. There are other sources contributing while we're making this measurement. It's not just we're in the cab and now we know exactly what changed in the truck that's making this
Yeah.
noise. We have no idea. We have to try and sniff around and find where the source came from. We're kind of coming into it where nobody knows when the noise started or what's going on. So first off, remediation and retrofit can be more complicated to address the actual source. Then the actual remediation when you're implementing it, it takes up downtime. You have to shut everything down to install the remediation. You need to take up some of your floor space, but it's still definitely possible. And if you're trying to look for more complex solutions, a lot of machines are going to be different. On the engineering side, if you engineer a solution for a machine, you can keep producing that equipment with this engineered solution, and now you're fine and dandy. All the equipment's going to be quieter. But retrofitting, you have to be specific to every unique machine and all of its unique issues and noises that it's making. So sometimes we move into modeling with statistical energy analysis, finite element analysis. That also has a lot more upfront costs. So essentially, retrofitting is gonna ravel into this more expensive, a little harder to address, but definitely not impossible.
It's funny how it's kind of facetious. I suppose you asked the oldest employee, when did you notice this noise started? You ever do that?
Yeah, we do. Yeah. Was it like this the whole time? Sometimes it
Yeah.
was, sometimes it wasn't.
Well, I'm glad that you do that. So often I think we design things and we forget to ask the people on the floor of, how does this work or has this changed over the years? So I'm glad to hear that you asked that.
For sure. For
And
sure.
so the costs are probably more when you retrofit, huh?
Yeah, proactively covering it can have like in a higher initial investment, but now you have the smaller footprint, less disruption, and long-term solutions. Where the retrofit usually it's urgency driven, and now the cost to fix it is just based on what the issue is. You have no idea how much it's going to cost. Then there's operational disruptions. So those are the kind of trade-offs that we have to work with.
I think you mentioned a few times about maintenance, being able to perform maintenance on equipment. And when you put barriers around it, then it makes it that much harder unless you've figured that ahead of time, how you're going to do
Yeah,
that.
we would
So
we would figure it ahead of time, but sometimes it isn't. It's not
it's a,
possible, I should
you
say.
might have to tear the whole thing apart.
Yeah.
Okay, and you get this question because I know you love this question. If you could solve all the world's noise complaints, what would be the best approach?
Yeah. I mean, the approach where you're setting a standard or a model that um, puts the pressure on the manufacturer, I think that's a great approach. I mean, it's the same kind of model they use for emissions in vehicles, for pollution at facilities. You set the standard, you provide incentives, and then now the manufacturers are working to produce something that's going to meet that standard because they want big companies to buy their equipment. They want to make the sale, and so having the large purchasers set that themselves or however that standard comes into play. Like centers are a good example right now. of this kind of practice where municipalities are they're pivoting, they're trying to address, okay, there's clearly a noise concern. They run 24/7, low frequency, and their ordinance don't account for that. But if they were to have, if municipalities had more strict ordinances or something that was a little bit more well defined, this is something that we're working on quite a bit, working with a lot of municipalities, then they would set that standard. And then now if a large, data center, hyperscale buyer, Google, Amazon, if they wanna move into this place, they have to meet that criteria, which means they need to purchase quieter equipment, which is now, the OEM wants to sell to Google, Amazon, whomever. So they're gonna produce quieter equipment. They're going to work on that quieter engineering. So having that standard work backwards is a great way to address just overall every facility is gonna benefit.
You mentioned data centers. I understand you're working with the data center group to look at some of these issues from MSU.
Yeah. Yeah, the Quello Center, they have a working group, and it's people who are advocates and or they work for data centers. So they could be the managers or um, involved in data center operations, as well as people who are advocates against data centers. It's just a full mixed bag, unbiased. We all get together and we talk about different departmental duties. Like I'm in the regulatory working group, so I had the pleasure of being able to speak about the noise aspect and provide a little more insight on how it is that we measure, how we address environmental noise issues, why noise ordinances fail. So it's a great group.
Um, any final thoughts? Can you explain noise conscious engineering? That's a phrase you used.
Yeah, yeah. I mean, the noise conscious engineering is exactly how it sounds. Like if you're concerned about heat buildup, then you'd be trying to be more conscious of the thermal aspects of what you're building. It's sensitive to if it gets hot, you have problems. So noise conscious engineering is just being aware that the every little component, one small detail could result in a noise issue, something that's tonal, something that's going to be intrusive and require some remediation. So I like to see when something was designed with noise in mind, rather than just hitting like a compliance number. Again, data centers, good example. They may be compliant in DBA, but there's other statistical measures for how noise is perceived, like DBC, where they wouldn't be compliant. And then also using psychoacoustics. So this is just involving that we are um, non-perfect listeners. Noise is subjective to us. My red that I see may not be the red you see. The same thing is true for sound. So to be noise conscious, it's also to include who's our receiver, how are they going to be, interpreting this noise, and addressing it not only in an objective, here's the measurable, quantified data, but also what is the user experience going to be like? Um, are we confident that they're going to be happy with this? And just really understanding the human experience that's associated with these objective values.
So it's a quality of life issue too. Absolutely.
Yeah, for sure.
Okay. Analyzing to determine hazards, including unwanted noise, is a basic part of the EHS professional's toolbox. Utilizing advanced engineering as part of that analysis is always a route to explore. I'd like to again thank Eli Franklin of Memtech Acoustics for his insights. He can be reached at elifranklin@memtechacoustics.com. If you have any questions about this podcast, the Michigan Safety Conference, if you'd like to be a guest or sponsor one of our podcasts, information can be found on our website at michsafetyconference.org. Thank you for listening to Safety Spectrum. This is Sheila Ide.